So now that we know what Express is, we're almost ready to start building our API. But before we do that, I need to quickly talk about APIs on a higher level, and more importantly, introduce you to the REST architecture, which is the most used API architecture today. This way, we will actually know what we're building. So it's extremely important to understand the stuff in this video before moving on, so that we actually know what we're building throughout the rest of the course. So first of all, API stands for Application Programming Interface. And on a very high level, it's basically a piece of software that can be used by another piece of software in order to allow applications to talk to each other. So we have actually talked about APIs before, more specifically web APIs, where we simply build an app that sends data to a client whenever a request comes in. So imagine we have our app running on a server and we have a client. And so in fact, we effectively have two pieces of software talking to each other, right? And this is the kind of API we will build in this course. And I guess it's the most widely used type of API out there. But in fact, APIs aren't only used to send data and aren't always related to web development or JavaScript. So the application in API can actually mean many different things as long as the piece of software is relatively standalone. Take for example the Node file system or the HTTP modules. We can say that they are small pieces of software and we can use them, we can interact with them by using their API. So for example, when we use the read file function from the FS module, we are actually using the FS API. And that's why you will sometimes hear the term Node APIs. And that usually simply refers to the core Node modules that we can interact with. Or when we do DOM manipulation in a browser, we are not really using the JavaScript language itself, but rather the DOM API that the browser exposes to us, so it gives us access to. Or even another example, let's say we create a class in any programming language, like Java, and then add some public methods or properties to it. These methods will then be the API of each object created from that class, because we're giving other pieces of software the possibility of interacting with our initial piece of software, so the objects in this case. So you see, API has actually a broader meaning than just building web APIs, alright? Anyway, a web API is what's most important for us in the context of Node. And so let's now take a look at the REST architecture to build APIs. So REST, which stands for Representational State Transfer, is basically a way of building web APIs in a logical way, making them easy to consume. Because remember, we build an API for ourselves or for others to consume, okay? And so we want to make the process of actually using the API as smooth as possible for the user. Now, to build RESTful APIs, which means APIs following the REST architecture, we just need to follow a couple of principles. First, we need to separate our API into logical resources. These resources should then be exposed, which means to be made available using structured resource-based URLs. To perform different actions on data, like reading or creating or deleting data, the API should use the right HTTP methods and not the URL. Now, the data that we actually send back to the client or that we receive from the client should usually use the JSON data format, with some formatting standard applied to it. Finally, another important principle of REST APIs is that they must be stateless. So this is a very broad overview. Let's now start talking about these principles one by one, starting with resources, and using the Natures API that we're going to build in this course as an example here. So the key abstraction of information in REST is a resource, and therefore all the data that we want to share in the API should be divided into logical resources. Now, what actually is a resource? Well, in the context of REST, it is an object or a representation of something, which has some data associated to it. For example, tours, or users, or reviews, in the case of the example that we're following. So basically, any information that can be named can be a resource, alright? It just has to be a name though, not a verb. Now, we need to expose, which means to make available, the data using some structured URLs that the client can send requests to. For example, something like this. So this entire address is called the URL, and this add new tour is called an API endpoint. So our API will have many different endpoints, just like these fictional endpoints that I have here, each of which will send different data back to the client, or also perform different actions. Now, there's actually something very wrong with these endpoints here, because they really don't follow the third rule, which says that we should only use HTTP methods in order to perform actions on data. So endpoints should only contain our resources and not the actions that can be performed on them, because that would quickly become a nightmare to maintain. So how should we use these HTTP methods in practice? Well, let's see how these endpoints should actually look like, starting with getTour. So this getTour endpoint is to get data about a tour. And so we should simply name the endpoint tours and send the data whenever a GET request is made to this endpoint. So in other words, when the client uses a GET HTTP method to access the endpoint. And just like this, we only have resources in the endpoint or in the URL and no verbs, because the verb is now in the HTTP method, right? And by the way, it's a common practice to always use the resource name in plural, which is why I have tours here and not tour. Now, the convention is that when calling that endpoint, we get back all the tours that are in the database, okay? But if we only want a tour with one ID, let's say 7, we add that 7 after another slash or in a search query. Or it could also be the name of the tour instead of the ID, or some other unique identifier. The detail doesn't really matter at this point, alright? Later, I will show you how easy it is to actually implement this kind of logic with Express, because this is actually where Express really shines. So, the first HTTP method or verb that we can respond to is get, and it's used to perform the read operation on data. Next up, if the client wants to create a new resource in our database, in this example a new tour, the post method should be used. So we learned earlier that a post request can be used to send data to the server, and so it makes sense to use post in order to create new resources, right? Now in this case, usually no ID will be sent because the server should automatically figure out the ID for the new resource. Anyway, what's really important to note here is how the endpoint name is the exact same name as before. So the only difference is really the HTTP method that is used for the request. So if the /tours endpoint is accessed with get, we send data to the client. But if the same endpoint is accessed with post, we expect data to come in with the request, so that we can then create a new resource on the server side. So that is really the beauty of only using HTTP methods rather than messing with verbs in the endpoint names. Again, that would really become unmanageable very quick. Alright, next, there should also be the ability to update resources. And for that, either a put or a patch request should be made to the endpoint. The difference between them is that with put, the client is supposed to send the entire updated object, while with patch, it is supposed to send only the part of the object that has been changed. But both of them have the ability to send data to the server, a bit like post actually, but with a different intent. So post is to create a new resource, while put or patch are used to update an existing resource, and so that makes all the difference. And finally, to delete a resource, there is the delete HTTP method. Again, the ID or some other unique identifier of the resource to be deleted should be part of the URL. Now, usually, in order to actually be able to perform this kind of request, the client must be authenticated. So basically logged into your app, okay? But that is, of course, a topic for much later. So these are the 5 HTTP methods that we can and should respond to when building our RESTful APIs, so that the client can perform the 4 basic CRUD operations. So CRUD stands for create, read, update, and delete. And you will see this term all the time related to APIs and database stuff. And you see that these HTTP methods map quite nicely to the basic CRUD operations. Now, there might be actions that are not CRUD. And in that case, we just need to get creative with our endpoints. For example, a login or a search operation. These are not really related to a particular resource, and they're not CRUD operations either, but we still can create endpoints for them, for example like /login or /search. But we'll talk more about these cases later in practice. And just to finish this part now, remember that we had two other crazy endpoint names in the last slide, which kind of involve two resources at the same time, right? And that's also no problem at all with REST. So getTours by user can simply be translated to users/tours. In this case, user number 3. So this particular endpoint here could send data about all the tours that user number 3 has booked. Make sense? Or in the case of deleting, there could be a delete request to the same or a very similar endpoint requesting tour number 9 to be deleted from user number 3. Okay? So there really are a tons of possibilities of combining resources like this. But of course, we don't have to implement all these combinations in our API. We only implement what makes sense in the case of our application and the client that wants to consume our API. So, this is how we make use of HTTP methods to build user-friendly and nicely structured URLs that are easy and logical to consume for the client. Now, about the data that the client actually receives or that the server receives from the client, usually we use the JSON data format. And so let's briefly learn what JSON actually is and how to format our API responses. So JSON is a very lightweight data interchange format which is heavily used by web APIs coded in any programming language, so it's not just related to JavaScript. And it's so widely used today because it's really easy for both humans and computers to understand and write JSON. So you're probably already noticing that JSON looks a bit like a regular JavaScript object, right? With all these key value pairs. There are, however, some differences, and the most important one is that all the keys have to be strings. It's also very typical for the values to be strings as well, but they can be other things, like numbers, true, false values, other objects, or even arrays of other values. So it's quite straightforward actually, and from this example you can kind of see how some typical JSON might look like. So let's say that this is the data that we have in our database for a GET request to this URL, so the tour with ID of 5. Now we could send it back like this to the client, but we usually do some simple response formatting before sending. There are a couple of standards for this, and we're going to use a very simple one called JSend. So we simply create a new object, then add a status message to it in order to inform the client whether the request was a success, fail, or error, and then we put our original data into a new object called data. Okay? And we can develop this even a bit further, but this is really the simplest way of formatting with JSend. And just by the way, wrapping the data into an additional object like we did here is called enveloping, and it's a common practice to mitigate some security issues and other problems. Also, there are other standards for response formatting that you can look into, like JSON::API or the OData JSON protocol. Alright, and finally, a RESTful API should always be stateless. So what does stateless actually mean? Well, in a stateless RESTful API, all state is handled on the client and not on the server. And state simply refers to a piece of data in the application that might change over time. For example, whether a certain user is logged in, or on a page with a list with several pages, what the current page is. Now, the fact that state should be handled on the client means that each request must contain all the information that is necessary to process a certain request on the server. Alright, does that make sense? So, the server should never ever have to remember the previous request in order to process the current request. So, let's take the list with several pages as an example, and let's say that we're currently on page 5 and want to move forward to page 6. So we could have a simple endpoint called tours/nextPage and submit a request to it, right? But the server would then have to figure out what the current page is and based on that, send the next page to the client. In other words, the server would have to remember the previous request. It would have to handle the state server side. And that is exactly what we want to avoid in RESTful APIs. Okay? Instead, in this case, we should create a tours/page endpoint and pass the number 6 to it in order to request page number 6. This way, we would handle state on the client, because on the client, we would already know that we're on page 5. And so all we had to do is to just add 1 and then request page number 6. So the server doesn't have to remember anything in this case. All it has to do is to send back data for page number 6 as we requested. And by the way, statelessness and statefulness, which is the opposite, are very important concepts in computer science and application design in general. So it's a good idea to actually have some understanding what a stateless API is and how it works. Anyway, this was a huge lecture, but also one of the most important ones. I cannot stress that enough, and I actually think that you can see that, right? Anyway, let's now finally get back to our code.